Okay, today we're going to be talking about transformations of functions, specifically horizontal and vertical shifts. So what you're going to be looking for is a number that's added inside the parentheses or added onto the end of a function. The number that is added inside the parentheses is the horizontal shift. So this is going to tell you it's going to go left or right, whatever C units comes out to be. It's important that you remember that the plus actually is moving it to the left and the minus is actually moving it to the right. Okay, so that's a horizontal shift. Your vertical shift is going to be determined by the number added onto the end. This one is going to stay the same sign though. So the positive means up, the negative means down. So just be careful with that one that's inside the parentheses because again, it's always an opposite sign. So if you start with a parent function of f of x and it changes to f of x plus 3, this means you're going to be shifting up 3 units because of that plus 3 at the end. If you see that it becomes f of x, it starts as f of x and becomes f of x minus 7, where that minus 7 is inside the parentheses, this means it's going to be shifting to the right 7 units. Okay, so be careful with that because again, I know you think minus means go to the left, but in parentheses, minus actually means go to the right. Okay, if I do a little combo of both of these put together, this plus 1 inside the parentheses means I'm going to go left 1, and this minus 4 at the end of the parentheses, when it's outside the parentheses, it stays the same sign, means I'm going to go down 4. Okay, in a similar fashion with number 4, now we're going to actually incorporate some actual functions, not just the names f of x. So we're starting with x squared. We're adding 3 inside the parentheses with x. So inside the parentheses means I'm going to be going to the left 3 units. This plus 2 at the end means I'm going to be going up 2 units, and that's my shift. Okay, with the absolute value, again, it's pretty straightforward. I have this minus 4 inside the absolute value, so that's like inside the parentheses. That means I'm going to be going to the right 4 units, and minus 1 means I'm going to be going down 1. And then I have y equals square root of x. That becomes square root of x plus 2. Pay attention to where this plus 2 is. Because it's underneath the radical, this means that this is the horizontal shift. It's like plus 2 being added inside the function. This means I'm going to be going to the left 2. If it was outside the parentheses, that's when I would be going up 2. If you ever want to check yourself, what you could also do is plug in, for example, like this last one, the square root of x, and I make that the square root of x plus 2. And then I take a look at the graph. So you can see the initial graph is here, and then what happens afterwards, it's shifted to the left 2 units. So that would be a good way to confirm what direction it's moving. The last question says, if the maximum point of f of x is the point 4, 2. So you don't even have to know what f of x looks like, just know that on this graph, there's the point 4, 2. It's saying state the maximum point of f of x plus 1 minus 2. So let's think about how this whole graph is being shifted. This plus 1 means I'm going to the left 1. This minus 2 means I'm going to be going down 2. So that means every single point on that graph is going left 1, down 2, including that maximum point. So take this, go left 1 and down 2, and that should end up at the point 3, 0. Okay, I would not specifically like plus or add or whatever to the actual coordinate pair. I think it's easier to graph it and then see where it ends up. Okay, so after we, in our last lesson, talked about transformations of functions using shifts, now we're going to start taking a look at what happens when it's stretched and compressed, a little bit actually also with some reflections, and then I'm going to put a little bit of everything together. So you'll notice this time I have a lot more letters as I go from f of x to my transformation of my function. So I'm going to point out what each of these letters actually represent. This negative in the front is going to represent a reflection over the x-axis. If there's a negative inside the parentheses, that would be a reflection over the y-axis. I don't think I included any questions like that, so I'm not even going to write that in right now. My a value, okay, so the number out front, that's going to be how we do a vertical stretch, okay, or compression. And what's going to happen is that if this a value is bigger than 1, it's a stretch. If the a value is less than 1, okay, so between 0 and 1, then it's going to be a compression. It's never going to go negative. If it's negative, it's actually a reflection plus some sort of a stretch or compression. You're not going to have to really worry about this too much, but it comes up in some of the multiple choice questions, so I just want to mention it. That b value would be a horizontal stretch or compression. And this one's a little weird because it's in parentheses. You have that opposite relationship once again. If that b value was less than 1, it's actually a stretch, and if that b value is more than 1, then it's actually a compression. Okay, so really focus more on the vertical, and again, imagine that's like someone taking your graph and pulling it from the top and bottom. Think of like a rubber band, how it kind of looks like it's horizontally getting compressed, but it's really getting vertically stretched. Now we had mentioned that C is your shifting to the left and right. So be careful, again, in parentheses is an opposite relationship. Plus goes to the left, minus goes to the right. That D value at the end, that's your vertical shift. So that plus is going to go up, that minus is going to go down. Now we're going to basically put a little bit of everything together. So if you take a look at number 1, I'm starting with a parent function of f of x, and it's becoming 2 times f of x. That 2 out front, that is my vertical stretch by a factor of 2. Okay, and so what you're going to be looking at really is you're going to see all your y values become twice as big as they were before. So again, that's why it looks like it's being stretched from the top and the bottom. Again, I'm not really going to ask you too many questions about this, but I'm just incorporating it in this one lesson because I know it comes up in one of those assignment questions. But f of 2x, where the 2 is on the inside, that would be a horizontal, and it's a little weird here because I know you see 2 and you want to think stretch, but it's actually a horizontal compression by a factor of 2. Okay, so everything comes out to be like twice or half as big, I guess you would say, because of the fact that it's getting horizontally compressed, so it's squished in from the left and the right. And again, that's opposite relationship because it's coming from inside the parentheses. With question number 3, you're starting with x squared, and it's becoming 3x plus 1 squared. Okay, so that 3 in the front, that's a vertical stretch by a factor of 2. Of 3, and this plus 1, this is a shift to the left, so be careful with that plus, 1 unit. Okay, with number 4, we have this negative in front, that's a reflection over the x-axis, so it's kind of look like it's flipping upside down. This minus 2, this is a shift to the right 2, and this plus 3 at the end is going to go up 3. With number 5, you're starting with x squared. This 1/2 in the front is a vertical compression, okay, by a factor of 1/2. So everything's going to be half as big as it was before. Imagine someone squishing it from the top and bottom. When you look at your graph, it's going to look a little wider, but it's really getting squished. That minus 3 means I'm going to be going to the right 3 units, and this plus 4 at the end means I'm going to be going up 4. Again, watch that relationship. In parentheses is opposite, at the end is not. And then finally, number 6, the negative is a reflection over the x-axis. Okay, this minus 1 that's in parentheses means we're going to be going to the right one, and this minus 1 at the end means we're going, minus 4 at the end means we're going down 4. Okay, so graphing parabolas with focus and Directrix is basically graphing parabolas with a vertical stretch or compression and a horizontal and a vertical shift. So what happens is we look at something called the vertex form of a parabola. Maybe I can put an A in the front of this. That A is going to be basically your stretch or compression. You have this H, which is going to be some sort of shift left and right, and that K is going to be some sort of shift up and down from your basic parabola, just plain old x squared. Okay, so before I get into focus and Directrix, we'll just talk about vertex form. The nice part about having this form is that right from this, you can read the turning point directly from the equation instead of having to worry about, doing some sort of calculation or plugging in your calculator or something like that. So again, think about the fact that plus 3 means that I'm going to the left 3 units. That's why my vertex is actually going to start with negative 3 as the x-coordinate, and then it's going to go down 2 units, so that's why my y-coordinate is going to be negative 2. Okay, so again, watch that opposite sign comes out of the parentheses, same sign with what's added on to the end. With number 2, I have y equals x minus 3, so this minus 3 becomes plus 3 when I make it the vertex, and minus 6 is like my vertical shift, and that's going to stay the same sign. So when you are doing parabolas with focus and Directrix, you're still going to have that vertex form. So you can get the vertex by looking at what's in parentheses squared and what's added onto the end. There's this additional thing called 1 over 4p in the front, which again, it's basically your vertical stretch or compression. But what you do is that once you plot your vertex, you use that p value to get to your focus and your Directrix. Basically what happens is that this parabola is representing all the points that are the same exact distance from the focus and the directrix. That's why the vertex has to be exactly in the middle of the focus and the directrix. So if I, let's say, had a p-value of 1, okay, that means I'm going from my vertex, I'm going up 1 unit. A positive p means my focus is going to be up 1 unit from the vertex. My directrix is going to be down 1 unit from the vertex. When you write the equation of your directrix, it's going to be like y equals whatever number that you're dealing with in that situation, and then your focus is going to be a coordinate pair. If it happened that your p-value, so like in this case, this would be like a p-value of 1, this would be like, again, the same distance 1. This is a directrix of y equals 1. If I, let's say, wanted to write the equation of this parabola, this has a vertex of -2, 2. Just if you wanted to write the coordinates out, the focus would be -2, 3. And then if I want to write the equation, I'd have y equals x plus 2 squared, because again, I'm switching that sign when it goes in parentheses, plus 2, because that matches the, like almost like the vertical shift, it's going to go up. And then to put the coefficient in the front, I'm going to do 1 over 4 times my p-value, which in this case is 1. So the equation of that parabola will be 1/4 x plus 2 squared plus 2. In the next situation, you'll notice that this parabola is upside down. So remember, that means that it's reflected over the x-axis. In this case, you're going to see that your p-value comes out to be -2. Because p is negative, that's why it's upside down. So notice that from my vertex, I'm going down 2 units to get to my focus. From my vertex, I'm going up 2 units to get to my directrix. Again, vertex is always exactly halfway in between them. This would be a line y equals 5. It's always going to be a y equals line for that directrix. So since my vertex is the point -2, 3, my equation is going to start as x plus 2 squared plus 3. Again, remember, watch that opposite sign when it goes in parentheses. And in the front, I put 1 over 4 times my p-value. So that's why the equation of this, based on the focus and directrix, would be -1/8 x plus 2 squared plus 3. So now if you have to actually sketch a parabola given one of these equations and find the focus and directrix and all that good stuff, start by figuring out first the vertex, because that's usually the easiest thing to get from the equation. Opposite sign of what's in parentheses, so that's 1, 2 for my vertex. So I plot my vertex as 1, 2. Okay? Then that 1/8, I'm going to set that equal to 1 over 4p. As I cross multiply, this gives me 8 equals 4p, or p equals 2. So from my vertex, I'm going to go up 2 units to get to my focus. From my vertex, I'm going to go down 2 units to get to my directrix. Okay, to technically make a proper graph, I should be going out 4 units, twice my p-value in each direction. Not from my vertex, sorry, from my focus. But I'm not going to focus too much on that right now, because really I just want you to be able to get a sketch of what this parabola looks like, and realistically you just need to be able to answer things like, what's the vertex, what's the p-value, and again, this p-value is 2. My coordinates of my focus, if I needed that, would be 1, 4, and the equation of the directrix would be y equals 0. Okay, the last one. So the last one I have, again, start with your vertex. That's the easiest part. Your vertex is -2, -1. So -2, -1 is my vertex. You'll notice this time I have a -1/4 in the front. So 1 over 4p equals -1/4. Cross multiply, this becomes 4p, -4p equals 4. So p equals -1. So for my vertex, I'm going to go down 1 unit to get to my focus. I'm going to go up 1 unit to get to my directrix, so it happens that my directrix is still y equals 0 in this case. Okay, this is my directrix. Okay, again, to technically get a full proper graph, I should, from my focus, going 2 p units out in each direction. But again, I don't think that really makes too much of a difference for this lesson. What you really need to be able to do is identify what's the p-value, what's the vertex. The coordinates of the focus would be -2, -2. And again, this is a p-value of -1. Okay, so then the last thing is I want to be able to write out the equation of this parabola based on this given information. You don't really need a sketch, but a sketch could help you, obviously, in terms of figuring out what you need to find out. So notice that we're given the focus and directrix. We're going to need to figure out the vertex, because that's a necessary part of that equation. Y equals 1 over 4p, x minus h squared plus k. Okay, so again, it's vertex form with the 1 over 4p in the front, and then we need to figure out our p-value to fill in that correct compression or stretch factor. So if I make a quick a quick sketch, my focus is at the point 2, 0. Now again, that's not my vertex, that's the focus, so I have to be careful. My directrix is y equals -2. Remember that the vertex is exactly halfway between the focus and the directrix. So my vertex is the point 2, -1. That means my equation is going to be y equals 1 over 4 times, again, my p-value, I'll come back to that, x minus 2 squared minus 1. So what's the p-value? The distance from the vertex to the focus is that you're going up 1 unit, so p equals 1. So your equation is 1 over 4, x minus 2 squared minus 1. All right, the last one. I have the vertex, so I can actually already start the equation. Y equals 1 over 4 times something, x plus 2 squared plus 1. The thing is, I have to figure out what's the p-value, so I'm still going to sketch it out. So my vertex is at -2, 1. My directrix is at y equals 3. Remember that the directrix is equally distant from the vertex as is the focus. So if it's 2 units to go from directrix to vertex, it's 2 units to go from vertex to focus. So notice that these 2 units, though, are by me going down, so that's why p-value is -2. Also, again, if I was going to sketch this parabola, it'd be upside down. It should make sense that it's going to have a negative in the front. Okay, so y equals -1/8, x plus 2 squared plus 1.